There are many important reasons for studying asteroids like the target of OSIRIS-REx, Asteroid Bennu. First and foremost, for me especially, they're geologic remnants from the dawn of our solar system. They're literally the first material that formed around our star, and they represent the building blocks of planets, and we hope, in the case of Bennu, of life, and the reason that Earth may be a habitable planet in the form of delivering water and other important volatile material.
When we look at asteroids, which are these primitive objects, these little leftover pieces from solar system formation, and we find they may have organics, then that tells us perhaps the conditions for life could have erupted anywhere in the solar system and Earth was just right.
When we study meteorites, we think they represent these asteroids and their different histories, but they've all interacted with the Earth's atmosphere, its biosphere, its hydrosphere. And so we don't know what effect just interacting with the Earth has had on these meteorites. We really want to get samples that are pristine, and so we can do all of those things through this mission.
OSIRIS-REx is a mission in the NASA New Frontiers program. Our objective is to travel out to a near-Earth asteroid named Bennu, survey that object in great detail to understand its geology, its mineralogy and composition, ultimately select a single location on the asteroid surface to acquire a sample, and return that material back to the Earth for scientific analysis.
Asteroid Bennu is a fragment of the early solar system, an unmelted, unaltered piece of the origin of the solar system. It preserved the ingredients, the raw materials that went into the formation of planets, the formation of life. By bringing a sample back to the Earth, such as OSIRIS-REx will do with samples of Bennu in 2023, we'll be able to look at the samples in laboratories around the world to understand in great detail the nature of the sample and its place in the origin of the solar system.
The OSIRIS-REx spacecraft launched in 2016, and it's actually taken us 2 years to get to the asteroid Bennu. And in that time, we had an Earth flyby. So we used an Earth flyby in 2017 to change the plane of our orbit to match Bennu's orbit plane. And it's also provided a great opportunity from a flight dynamics perspective to really calibrate our models and learn how to fly the spacecraft, which will help us in the really challenging part of the mission, which is orbiting in the low gravity environment of the asteroid. Over the past few months, the flight dynamics team has been getting images of the asteroid Bennu, and it started out as just a very small point source in the camera, and it's been getting bigger and bigger and bigger in the field of view. And that's allowed us to perform optical navigation to refine our prediction of the asteroid's orbit and allow us to more precisely navigate and target our approach to the asteroid.
As OSIRIS-REx approaches the asteroid, we've done a series of braking maneuvers called asteroid approach maneuvers to slow down the spacecraft so that we can get into orbit around the asteroid later this year. We're also taking lots of images of Bennu to understand its rotation, look for natural satellites, and potential dust plumes.
This is an extremely exciting time on OSIRIS-REx as we're just poised at arrival at Bennu. And one of the most exciting things to us, and relieving too to the engineers, is how closely the asteroid has resembled what we had predicted. Early on, our science team, prior to launch, had come up with a model of what they thought the asteroid would look like based purely on ground-based radar observations from Arecibo. And from that, they created a reference asteroid that we used as the requirements to design the mission against. But no one could be sure that the asteroid would really look like the scientists had predicted. So it's been a tremendous relief to us to find that the actual Bennu is very similar to what the scientists had predicted. So the science team really nailed it.
Well, right now, as we're approaching asteroid Bennu, we're looking for debris or other objects that are orbiting the asteroid, just in case we need to avoid those. And then once we arrive on December 3rd, we'll perform preliminary survey. And in preliminary survey, we fly over the North Pole, South Pole, and the middle of the asteroid. This helps us to map the gravity of the asteroid and understand how to operate near such a small body. Additionally, this will be the first time that we get close-up pictures of the surface, and we'll know how smooth or rocky the surface that we're going to study is.
As we get closer to asteroid Bennu, we'll begin to map its surface in higher detail. What we'll be able to do is first identify the distribution of rocks and particles that might pose a hazard to the sampling mechanism on the spacecraft. And we'll also get a better sense of what the shape of Bennu is like at smaller scales. Looking at Bennu in more and more detail is going to help us identify all the areas that we shouldn't go to grab a sample from.
Throughout 2019, we'll be doing global characterization of the asteroid, basically making maps of the entire surface. We're interested in its topography. Are there craters? Where are the boulders, the valleys, the mountains of the asteroid? And then we want to understand the distribution of geologic materials. Are we finding different patches of minerals in one location versus another? And why are certain areas have a composition and others may be different? We're going to be looking most importantly for areas where we can collect a sample.
OSIRIS-REx will collect a sample from Bennu using our TAG-SAM, which is the Touch and Go Sample Acquisition Mechanism. What that is an arm connected to this sampler head that you see here. This is similar in size to an air filter from a car. How this mechanism works is there's compressed gas that is released that will stir up the regolith from Bennu, store it into this canister, which we will then put inside of our sample release capsule and bring back to Earth. We will collect the sample of Bennu in 2020 and return it to Earth in 2023.
Once we're in the vicinity of our home world, about 4.5 hours before impacting the top of the atmosphere, the spacecraft spins up and releases that sample return capsule. The spacecraft fires its engines to perform a deflection burn, going off into orbit around the Sun, and the return capsule enters the Earth's atmosphere, targeting a landing in the Utah desert. I'll be there on site when we open that capsule up and we see those samples for the first time, and science begins at that point on the next phase of the mission, the sample analysis period.